Alright guys, I'm not here today, but we're going to pretend that I am here. And you're going to go ahead and get your notebooks out and let's talk about volume of cylinders and cones. I made you guys watch a video, if you guys did, on understanding the formulas of volume of cylinders and cones, but the big idea is, what's this word volume even mean? In like a water bottle, how much water would be in the actual bottle would be the volume of it. So if I was to draw a cylinder, and go ahead and try to draw a cylinder the best you can. It's kind of difficult at times to make sure you draw it properly, but the cylinder here, like I said, if this was a cylinder of water, the volume would be how much water would be in the cylinder, okay? There's a formula for this, and what's going to happen is, if you were to break this cylinder down and like crunch it to like basically be flat and open it up, it would be the cylinder. You would unwrap it, it would just be a rectangle, the first part. But these bottoms, you obviously see that these are circles. They look like ovals from here, but they're circles. So really it would look like this if we were to make it completely flat. So you would have these two circles here, here, and then you would have your rectangle. So the formula kind of deals with the area of a circle, which is pi r squared. It deals with that, and then it also deals with this height. Okay, the height of the actual cylinder. Now, as I move on, I know it's hard for me to just teach this with an iPad lesson, but I want you to try to, try to put your mind in the idea of this whole thing going on here. Okay, now imagine a Pringles can. Let me try to draw this good. Pringles can. Let's keep trying to draw a straight line here. And your Pringles can is here. And we're going to imagine the volume would be how many Pringles, basically, you could fit in here, right? How many chips you would think about. And we're going to imagine these Pringles are straight, flat like this. So we're going to think like this. So imagine the whole thing was full of Pringles. And if I told you that the Pringles radius, and that's a word you need to understand. So imagine this is the bottom of the can. I'm going to make it bigger. The radius would be from the middle to one side. That's called the radius. So I would write that in your notes. The radius. And let's say the radius is going to be 1.5 inches. 1.5 inches. And the height is important as well. So what if the height was going to be from here to here? Let's say it's 12 inches. And the question asks, what is the volume of this Pringles cylinder? Your formula, make sure you have it written down. Your formula for volume of a cylinder is pi radius squared, pi r squared, which is basically the area of a circle, times the height. That's how you find the volume. That's huge in your notes. Make sure you write that down. Volume of a cylinder. Okay, and to plug it in, you're literally just going to go pi, which you're going to use 3.14. We're going to use that for pi. So make sure you understand that that is pi. You guys know this. You learned this in 7th grade. Okay, pi, radius. What's the radius? 1.5. But it's not just radius. It's radius squared. And then what's the height? 12. And that is basically how you calculate the volume. You just plug it into the calculator. You could do this, by hand, but I would suggest plugging it into the calculator and getting your answer. After I've done that, and hopefully you guys have a chance to do that, you're going to get 84.78. I want you to round to the 10th. Again, the 10th is here. This is the 100th. That's the 10th. This is the 10th. So you're going to round this up. So if this 8 is bigger than 5, 5 or larger, 5 or more, let it soar, 4 or less, let it rest, I think. So you're going to be 84.8, correct? 84.8. 0.8. Let me get the pen going here. 8. and that's your final answer. You would actually put it in inches, and what's interesting here is it's inches cubed. So that's kind of an interesting label that we're going to have here. Inches to the third power. That's how it works with volume. It's almost like when something's in 3D, like this shape is 3D, three-dimensional, it's going to be to the third power. When it's in 2, when it's just an area of something, that's squared. So we'll go over that too in detail. So 84.8 wasn't too tough, all right? Now, there's one other thing I want to teach you. We just talked about cylinders. So we have a cylinder, okay? Awesome. There's one more thing I want to talk to you about. Instead of the cylinder, I'm going to take the cylinder and turn it into a cone. And I know, try to draw this as best you can. And I want you to kind of even shade in the area of where the cone would be inside the cylinder. I know it's messy. Yours should be better. So, the formula for a cone is very similar to the formula for a cylinder. The formula for a cone is basically the same idea as pi r squared times height. It's the whole idea behind it. It's the same thing. Because you basically you're still going to have a radius here. Okay? You're still going to have that radius. And you're still going to have the height. The height of your cone, let me do this in red too. The height of your cone is still going to be the same height as your cylinder. Okay? But the thing is, if you see where this blue is, all of this stuff's not being used, right? In this cylinder. All of this space is not being used in the cylinder. So you have to think about that. And it wouldn't be the same exact formula because this would be included in that formula. So instead of just having it just be this formula, we take this pi r squared times height and we cut it into basically a third of that. It's only a third of that. So this whole cone is only a third. The other third of the cylinder is here and the other third is here. So we want to make sure we only calculate this middle cylinder here. So the formula is basically what you see here, but I'm going to put one last step into it, only one step. That's why it's not too hard. You guys can learn this, no problem without me. It's all of this divided by 3. You divide that into thirds, you're going to get your answer. Okay? So we're going to do the same exact height we had last problem, same exact radius. So if you remember, it was 1.5 was the radius, and the height was 12 inches. So we're going to plug this in again, and we're going to use 3.14 for pi, 3.14 for pi, r squared, and we're going to say, what was it? It was times 12. And if I recall again, our answer was 84.8, okay? That was our answer for a cylinder. Now we're going to cut that into a third of that. I only want to know what 1/3 of that is. So you're just going to divide that by 3. So 84.8 divided by 3 is going to be 28.26. 28.26. Now can I round that up? This tenth can round up, right? So really it's going to be 28.3. And it's going to be inches cubed. And that is now the volume of the cone versus the cylinder. All right, now I want you to have basically your homework for tonight, and I want to start it on, get it going for you guys so you guys don't have any issues. This side will be your cones, practice solving with cones, and the other side is actually what I wanted to start on. Hold on. So this is the side I wanted you to start on. Most of these, these two are pretty straightforward. I'm actually not going to solve it all, but I'll help you set it up. Even gives you the formula there. You're just going to use that again. Your R, make sure you always are looking at the radius, because a lot of times they're going to give you the diameter, okay? So what would the diameter of this one be? It would just be 8, right? So if they gave you 8, you know you should be using the radius, which would be half of that, which would be 4, which is actually what we have here, 4. So it's going to be 3.14 excuse me, times 4 squared times the height, which is 9. All right? You're going to punch that in the calculator. You're going to get your answer. You're going to round to the 10th. Okay? As I go down to the bottom here, be careful. Again, I said the diameter word you got to worry about. On all of these, you have to worry about the diameter. So the diameter of can of beans, So a can of beans may not be very big, but it's still going to be a cylinder, okay? The diameter of 3 inches. So you have to cut 3 in half because if the diameter is the whole thing, it's 3 inches. We only want the radius. And half of $3, if you had $3, you would give $1.50 each, right? So 1.5 is actually your radius here. And then for this one, 12 inches is your diameter, so the radius would be 6. Make sure you're careful on that. All right, flip it over real quick. Let's talk about the cylinder, or in the cones, excuse me. And again, very basic. We're going to go 3.14 times 3 squared, which is the radius here, 3 squared, times the height. And remember, all divided by 3. Okay, so that's set up. Round it to the 10th. I'm not going to do it for you. You guys can handle this. And as we move down here, number 4, again, and now I have a diameter. Should not be too difficult. That diameter again, so if it's 10, you know your radius is going to be 5, okay? You guys got this. No big deal. You do have a quiz on this tomorrow. It's going to be open note, and you're going to get to use this homework as well. What I want is tomorrow you turn in your quiz and your homework in two different piles. I want your homework turned in and I want your quiz turned in. So guess what? If you didn't finish your homework quite after that quiz, you want to finish it right after the quiz, I would suggest that. I want this done. Calculators, we should have enough for you guys to use. If you have to share, that's fine, but do not share answers. Just share the calculators. All right, guys? Best of luck and get this done. These are points that are going to go right before your progress report, your quarter 3 progress report.